In part 1, we left the branches of our tree just floating in space exactly the way that trees don't. Now we need a trunk, but this calls for a little thought. I will be wanting to 3D print this, but obviously the tree shape is simply not going to print as one piece. I suppose I could split it in half vertically and glue it back together, but that would be awfully hard to make the seams disappear. That would also be a problem if I wanted to print a tree larger than the build plate. Instead, I'm going to print each tier of the tree and a separate trunk. The tiers of branches can then slide down the trunk and glue into place. Preferably, the glue point should provide a decent surface area and should force the height and rotation of the tier so it all comes together with minimal effort. This can be accomplished if the trunk gets thinner as it goes up, and if it has shoulders or shelves placed where each tier should go. Each of those shelves needs to be sized such that the lower tiers can pass them as it's assembled. I'm going to build this trunk one tier or level at a time. To start, hide everything but the first tier. A good way to fit it all together, provide a good gluing surface, and control the rotation is to make the shoulder and the trunk contoured to the underside of the tier. Create a primitive cylinder. It gets placed with its vertical axis on the origin so it's already well aligned with the tiers above. Give it a radius of 5 mm and increase the height until it comes out completely above the top of the branches. Hide it away for a moment. We're going to make a cutting tool for it. Select all of the lower surfaces of the first tier and create a sub-object shape binder. There is a hole right in the center, and that's going to create havoc with the split apart operation when forming the shoulder. So select the shape binder and the connect tool. This use is not much like the example in the FreeCAD documentation, but it's a great tool for this. Hide away the populated array just so we can see it more clearly. Select the connect, and in the data pane increase the tolerance to 2 mm. The 2 mm tolerance is enough that the connect tool gets the idea and closes the hole for us. Make the cylinder visible. Select the cylinder and the connect, then part, split, slice apart. Select and hide the part of the split we want to throw away. This leaves a good shoulder for the first tier to rest on. Create another cylinder. Set its radius to 4.2 mm. Right-click the cylinder, transform, and lift it up so that it's growing out of the shoulder piece we just created. Make sure there's no gap at the bottom. There's the shaft of the trunk with the shoulder. Almost done. When assembling, the first tier is going to need to be able to slide down the trunk and come to rest on the shoulder. So cut a hole for that cylinder to fit through. Select the populated polar array, select the cylinder, and cut. Clearly something has gone wrong. The cylinder is still there embedded in the cut. I strongly suspect this is that minor misalignment issue that sometimes happens with lattice 2 arrays, where the piece almost but doesn't quite come together. This creates an unintentionally complex geometry that wreaks havoc with the cut operation, but it can be fixed in the same way I fixed it in a previous video. Undo the cut, select the array, and connect. The tolerance will fill in any of those little gaps. Select the connect, the cylinder, and cut. That's exactly what we were hoping for. You can see through the hole that the tier will rest very neatly on the shoulder. The cylinder used for the cut remains available to be incorporated into the trunk and to have further operations performed on it. We're creating a lot of objects here and the model tree is getting cluttered. So before it gets out of hand, rename the cut to Tier 1 to help keep track of it all. Now repeat the process. Make the second tier visible and increase the height of cylinder 001 until it protrudes through the top of the tier. Hide everything else and start selecting the undersurface. Create the binder. Select the binder, select the Connect tool, and we have a failure with an error. Shapes are of different dimensions, edge and face, and cannot be merged or compared. This means that somewhere along the way, when I was selecting surfaces, I accidentally also included an edge into the shape binder. It would be really hard to figure out where, so the quickest way to fix it is to delete the binder and do it again, being more careful this time. Try to connect again. This time it gives no complaint. Like last time, increase the tolerance. 1 millimeter is sufficient this time because the size of the hole was scaled down. Bring back the cylinder, select the cylinder, and connect, and again, part, split, slice apart. Hide the part we don't want. Hide away the slicing tool. I'll bring back the slice from the first tier so we can see how it's all going to fit together. I actually worked out the cylinder radii in advance, starting at 5 millimeters and scaling by 0.8 just like the branches. At this point I realized that I had a Thinko and made the second primitive cylinder 4.2 millimeters in radius when I meant 4. Not a problem. Parametric design to the rescue. Just open up the exploded slice 001.0, open the slice inside. Select the cylinder. That's the basis of this slice. In the data pane, change 4.2 millimeters to 4 millimeters. Problem solved. Just like last time, create a primitive cylinder and go on to the next tier. Now just keep going until we get to the top. For tier 4, the last tier, skip creating the additional cylinder and doing the cut. I'll probably put some kind of topper on this tree, but I haven't designed it yet. Whatever it is, I'll do the cutting then. Now hide all the tiers away. Make the slices visible. For each of the exploded slices, we want slice 0. Select them all and fuse. Rename the fusion to trunk just to make it clear. I did this design mostly to look at feasibility. I'm thinking of actually designing a base for it and some electronics to wire LEDs into it as a Christmas display. I can cut a channel in the trunk and hide the wiring in the open spaces where one layer goes into the next. But in the process, there were some interesting techniques that I thought I should share. If I do get further with this design, I'll be sure to update everybody here. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.